Title: Beginner's Guide to Robotics in 12 minutes. Introduction to Robotics. Welcome to the exciting world of robotics. Robotics is the intersection of engineering, electronics, computer science, and AI, allowing us to create machines that can perform tasks autonomously or semi-autonomously. Robots can sense their environment, make decisions, and take actions. Today, we'll walk you through the core components of robotics, from basic concepts to hands-on tools to get you started. Section 1. What is a robot? A robot is a machine capable of carrying out a series of actions automatically. While robots come in all shapes and sizes, they generally share these three main components. Sensors. Robots use sensors to gather information from their surroundings, like cameras or touch sensors. Processing unit. This is the robot's brain, where it processes information and makes decisions, usually a microcontroller or microprocessor. Actuators. Actuators allow robots to take action, like motors for movement or grippers for picking things up. Section 2. Types of robots. Robots are diverse. Here are the main types based on their functions. Industrial robots, used in manufacturing like robotic arms. Mobile robots, robots that can move like drones or self-driving cars. Humanoid robots, robots that mimic human actions, often used for assistance or entertainment. Social robots, designed for interaction, such as educational or companionship robots. Each type has unique design requirements and uses different components. Section 3. Core components of a robot. Let's look at the core building blocks. Microcontroller or microprocessor. This is the processing unit or brain of the robot. Beginners often use Arduino or Raspberry Pi to program their robots. Arduino. Great for simple tasks and easy to use for beginners. Raspberry Pi. A small computer capable of running complex programs, ideal for advanced projects. Sensors. Sensors allow the robot to detect its environment. Common sensors include ultrasonic sensors, measure distance, infrared sensors, detect proximity and obstacles. Cameras, used for vision-based applications. Actuators and motors. Actuators allow the robot to perform actions. Motors, DC motors for continuous rotation, servos for precise movement, and stepper motors for high control. Grippers, used for robots needing to pick up objects. Power supply. Batteries or power adapters supply energy. Make sure the power supply is compatible with the components you're using. Section 4. Building your first robot. Here's a step-by-step guide to building a simple robot, like a line follower or obstacle avoider. Step 1. Gather components. For a basic robot, you'll need a microcontroller. Arduino is great for beginners. 2 DC motors for movement. An ultrasonic sensor for obstacle detection. Motor driver, to control the motors. A battery pack. Step 2. Assemble the robot chassis. The chassis is the robot's body. Attach the DC motors to the chassis, connect the wheels, and place the battery pack securely. Step 3. Connect the microcontroller. Attach the Arduino or microcontroller to the chassis. The microcontroller should be in a stable position to prevent disconnections during movement. Step 4. Connect the sensors and actuators. Ultrasonic sensor, mounted on the front for obstacle detection. Motor driver. Connect the motors to the motor driver, and then connect the motor driver to the Arduino. Step 5. Power the robot. Connect the battery pack to the Arduino or microcontroller. Ensure all connections are secure and that the power supply matches the voltage requirements of the components. A reliable power setup is essential for smooth operation. Step 6. Programming the robot. Now that the hardware is set up, it's time to code. Start with simple commands to control the motors and sensors. Here's an example for an obstacle-avoiding robot using an ultrasonic sensor. Motor control. Program the motors to move forward by default. Obstacle detection. Use the ultrasonic sensor to detect objects in front of the robot. If an object is close, program the robot to stop, reverse, or turn to avoid it. Upload your code to the Arduino and watch as your robot starts moving and reacting to its surroundings. Step 7. Testing and troubleshooting. Run your robot and observe its behavior. It might not work perfectly at first, which is entirely normal. Here's what to check if you encounter issues. Connection. Ensure all wiring is secure. Power supply. Verify the battery charge and connections. Sensor readings. Make sure the sensors are functioning correctly. Programming logic. Double-check the code to ensure it's programmed to respond to obstacles properly. Making small adjustments and retesting is an essential part of building and refining your robot. Section 5. Advancing your robotics skills. Once you've mastered basic robots, you can explore more advanced topics. Here are a few ideas. Machine learning for robotics. Apply machine learning algorithms to enable robots to recognize objects, adapt to environments, and even learn from past interactions. TensorFlow and PyTorch are popular frameworks for this. Computer vision. Dive into computer vision to enable robots to understand visual data. For example, a robot with a camera and OpenCV, an open-source computer vision library, can recognize faces, track objects, or even read text. Robotic arms and manipulators. Try building a robotic arm with multiple joints and actuators. These arms are used in manufacturing and can be programmed to perform precise movements or even pick up objects. Autonomous navigation. Develop robots that can navigate complex environments independently. This requires working with sensors like LiDAR or GPS and implementing algorithms like SLAM, simultaneous localization and mapping, to create maps and navigate them. Internet of Things. IoT. Integration. Combine IoT with robotics to create connected robots. This can involve remote control via the internet, data logging, and even cloud-based processing for complex tasks. AI and natural language processing. NLP. With NLP, you can make a robot that understands and responds to human speech. This enables robots to interact with humans more naturally, adding applications in customer service, healthcare, and personal assistance. Section 6. Robotics resources and next steps. Here are some resources to continue your robotics journey. Online courses. Coursera, robotics specializations by universities like Stanford and UPenn. Udacity, robotics engineer, nanodegree. Machine learning, nanodegree. Books, robotics, vision and control. by Peter Cork. Introduction to Autonomous Robots by Becky and Goldberg. YouTube channels. The Robot Academy provides tutorials and insights on different robotics topics. Jeremy Blum, known for in-depth Arduino tutorials. MIT OpenCourseWare. Great resources on robotics and AI. Communities and forums. GitHub. Explore open-source robotics projects, libraries, and code samples. Reddit. Subreddits like r/robotics and Arduino for support and discussion. Stack Overflow. A great place to ask questions when troubleshooting programming issues. Conclusion. In just 12 minutes, we've covered the foundational concepts of robotics, including what robots are, types of robots, core components, building your first robot, advancing your skills, and valuable resources for learning. Robotics is a vast and evolving field with limitless potential. By starting small, continuously experimenting, and building on what you learn, you'll be able to create robots capable of remarkable things. Remember, robotics combines engineering, creativity, and problem-solving, skills that make every step of this journey exciting and rewarding. Thank you for watching, and welcome to the world of robotics. And join us for more interesting videos on Leo Storia.